Hello guys, welcome to Kunku Academy. In this tutorial, we'll be treating random variables, and under random variables, I'm going to explain all the concepts that we need: discrete random variables and continuous random variables. If you are new to this channel, I recommend that you subscribe and put us on post notification. Let's move on to today's topic. Now, we already know what a sample space is from our previous videos. So let's move on to this example. So I'll use it to explain what a random variable is. The sample space giving a detailed description of each possible outcome when three electronic components are tested may be written as. So three electric components are tested, right? So we want to determine whether they are defective or non-defective, and the defective is represented by D, right? So this is defective, and non-defective is represented by N, so non-defective. So it is three components that is selected at a time. So when we select, let's say we have three electrical components, so we test, and we determine whether it is defective or non-defective. It is defective or non-defective. So with the first instance, we saw that all was non-defective. With this one too, the first two was non-defective, the last one was defective, like that. So what a random variable does is that it represents or associates elements in the sample space with real numbers or numbers. What do I mean by that? So let's say we are defining a random variable. So normally we represent it by x. You can represent it by any variable. So we say that let x be defective component, right? So we are saying that our random variable is x and it represents defective component. So we represent if we have one defective component, we say x is equal to 1, right? So with this, it means that we should look for all the elements in the sample space which has just one defective component, right? So what is the maximum number of defective component that we can have? That is 3, right? Because we are selecting 3 elements, and it's only possible for 3 to be defective from the 3 elements, right? So the thing is, what random variable does is that it represents this defective component by numbers, right? So we can see when we say x equal to 0 now, we mean that find the element in the sample space with no defective component. When x is equal to 2, find element in the sample space with just 2 defective components. I hope you get it at this point. So that's what random variables does. What they do is that they associate elements in the sample space with just numbers. So we can choose to represent non-defective components with our random variable. So you can say let y be a non-defective component. So with this case, when I say y is equal to 2, then I mean that find the element in the sample space with 2 defective components, right? So with this, now y will be with 2 non-defective, so y will be this. So it's just this 3. So when I'm representing y to be n, n, d, n, d, n, d, n, n. So for random variables, it's you that would define what your random variable should represent, right? So before you start any question, I'm just saying this ahead because you'll be using this to solve probability distributions and everything. So I want you to really get it. So before you start any question, you need to really know what your random variable describes, right? Because it changes when it is described differently. Like I said, for this, you see x represented defective component. So if I tell you to find x is equal to 2, you are not going to get this sample space. If like, let's do it and see. So find x equal to 2. X is defective component. So with that, you are going to select this, this, and this. So you see it is different from when we represented it by a non-defective component. So I hope you get it up to this point. So that is what a random variable basically is. Now let's look at this example so that you get to understand. Look, two balls are drawn in succession without replacement from an, I don't know how to pronounce this, containing 4 red balls and 3 black balls, right? The possible outcomes and the values y of the random variable capital Y. Okay, now let me explain this. Now you see, like I said, random variables just associate numbers to elements in the sample space, right? So when I say y is equal to non-defective component, right? And we know that just three, for this question, just 3 elements were taken at one time, right? So y has a range. So y can be either 0, 1, 2, or 3. It cannot be more than that because we have just 3 elements. There can be either no defective item picked, one defective item, 2, or all of the items that were picked will be defective. Yes. So with this case, right, each element, right, so all this is represented by this big Y. So each element or each occasion in this big Y can be represented by a small y, right? So represent it by a small y. That is the main difference. So with this question, right, two balls are drawn in succession without replacement from an, or I don't know how to pronounce it, containing 4 red balls and 3 black balls. The possible outcomes and the values y of the random variable y, right? The values small y of the random variable capital Y, where y is the number of red balls. So this is the definition of what the random variable is. So y is equal to what? Number of red balls. Now number of red balls. Now small y represents any occasion in this big Y, right? So with this, just 2 balls are taken. So with these 2 balls, it's either we have no red ball taken, 1 red ball taken, or 2 red balls taken, right? So each of this is a y, a small y. So each of this is a small y. So this big Y can be either of this occasion, right? So with this, it is either a red ball. So this is the sample space, right? So you can use a factor tree. Let me just use a tree diagram. So the first occasion can be either a red ball or a blue ball, right? And the second occasion can be either when the first occasion is a red ball, the second occasion can be either a red ball or a blue ball. When it's a blue ball, it can be either a red ball or a blue ball, right? So now our sample space should be red, 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 blue, blue, red, or blue, blue, right? So this is our sample space. So our random variable is number of red balls. So this, for this, y will be equal to what? 2 for this, because we have 2 red balls. For this, y will be equal to what? 1. For this, y will be equal to 1 because there's only 1 red ball. For this, y will be equal to what? 0. So I hope you now understand the definition of what a random variable is. Now let's move on to the types of random variables. So the types of random variables. So random variables, we have just two types of random variables. So we have discrete random variables or continuous random variables. So what do we mean by discrete random variables? So when discrete random variables are under discrete sample species, right? So when the set of possible outcomes are countable, or even if they are even if they are uncountable, they should be finite, right? If that is so, then it is discrete, right? So let's say we toss a coin, right? We toss a coin. When we toss a coin, we have just two outcomes, right? We can count these outcomes, right? It's either a head or a tail. Or when we toss a die or roll a die, for that one too, we have just six outcomes, either 1, 2, 3, 4, or 5, or 6. For that one, we can also count, so it is discrete. But when we have infinite number of possibilities, right? If you have infinite number of possibilities, then our variable will be continuous, right? Our variable will be continuous. Now this um, tutorial was just to explain what random variable is, because it's very, very important. And if you do not understand this, your whole probability course will be rough. So I just wanted to explain this. I'm going to take my time to explain what discrete probability distribution and continuous probability distribution is in the next videos, because I don't want this video to be long. Thank you for watching this video to the end. Do well to like, comment, and subscribe.